How's it going, everybody? I'd like to give everybody a quick shout out on the channel. Everybody that's been a subscriber for a while, or if you're brand new, I would like to welcome you to the channel. Thank you for your subscription. Thank you for the continued support. You guys have been blowing it up lately. For those of you that did not know this, INE has released both the CCNA Service Provider Part 1 and Part 2 video series. So it's right around 40 hours worth of content to help you earn your CCNA in Service Provider. So that is now done and ready to go. Now, one of the things that I'm working on now is a vendor agnostic video series. I was going to say certification. Because of the fact that I'm studying for my service provider in CCIE, then in CCIE, my service provider CCIE, I am dedicating a lot of time and effort to that. One of the things that I'm working on is a workbook for that. I know I made mention of that, and I have actually decided to move forward with that option. I'm actually hoping to add another plaque like this one here soon, and I'll have to figure out where I'm going to put that one so that I get them to both show up in the video. So what I'm doing here in this video, for those of you that are not as familiar with ISIS, this is going to be kind of like a design to understand like the high level overview of it. For any of you that are working on, say, CCIE and route switch or anything else, that's pretty much where this video is set up for, is to give you a 10,000 foot view, or potentially higher or lower depending on your level of understanding, of intermediate system to intermediate system. As a friend of mine, his name's Matt, he likes to make fun of me when I type in ISIS. I make it look like it's ISIS, and that is totally not the case. So this is definitely going to be IS to IS, which is router to router, if you did not already know that. So I'm actually looking at doing a very deep dive on ISIS here soon. A lot of, and the way that I'm doing that is I'm planning on recording a bunch of videos on the actual content first and walking you through the configs and stuff like that. And then there's going to be a workbook that's going to be a supplemental learning option that I'm working on that will allow you to go through the labs that I'm doing that are, you'll have like a topic, like for instance the one I'm looking at. I can't show you the workbook yet because it's still in development, but for instance one of the examples could be like ISIS base configuration, where I walk you through a topology and I explain where you're going to need to enable ISIS and how you need to enable it. And I go through, and it's basically built so that it's going to be laid out so that you're building OSPF, ISIS, BGP, MPLS, layer 3 VPN, inter-AS VPN, carrier supporting carrier, multicast, quality of service, layer 2 VPN. Basically everything you can see on the service provider blueprint, or as an option for service provider. I'm going through that content, and I'm going to be doing that. So it's going to be a ground up build. So you're going to be focusing on the technologies, not on the certification. So I felt like that's a good way to keep it not certification specific, because a lot of times a certification can kind of we have a term here in the U.S. It might be outside the U.S. as well, putting the blinders on. What that means is you're not going to look outside of the area you've been told that you're going to have to be knowledgeable in. Even though Cisco kind of gives you an out stating that any other topics as we decide. Well, in my experience, they don't go outside of that. They really try to stay inside of it. So this is going to be, we're going to be dipping into topics, like for instance DMVPN. We'll be hitting that. We're not going to go through like protocol level detail on NHRP, but it is applicable for MGRE, L3 VPN, stuff like that. So it's definitely an option out there for you as an option as you're going forward in your prep. So there's a lot of different things. I'd like to give a quick shout out to two people that I know just recently passed their CCIE and service provider. First guy's name is Nick. The other guy's name is Luke. I won't give out their last names, but if you were to look them up, like Google CCIE SPB4, Luke and Nick, you'll be able to find them. They both have, I know Nick used a gentleman by the name of Daniel Dibb, good friend of mine. He passed his SP exam, I think, a couple of months ago, and Luke just passed his about a month ago. So I've actually been utilizing their experience from the lab to help me gauge the direction that I should be doing all of the stuff for the service provider stuff that I'm working on now. And the main reason why I'm doing this is because I haven't found anyone online, at least in my, because I'm like, I've committed myself to service provider. I mean, I've put the security, data center, wireless, VMware, I've shelved all of that. And I find when I shelve something, and I commit myself to just one particular track, and I'm already very familiar with the majority of the topics, I can breeze right through it. But right now I'm focusing on ISIS. So I've actually got the workbook topics pulled up in front of me, and I'm going to go through a small network topology, as you can see on your screen. Sorry for the interruption. I am going to take a high-level overview of all of the main topics, and we're not going to go deep, but we're going to discuss what they are and some of the different options for that. So first things first, what I'm going to do is I'm going to come over here and I'm going to draw this out, and I'll be mindful that you should be sitting somewhere. You should see me right. Actually, let me kind of do this real quick. I should be sitting right there in your picture view. So. Or thereabouts, so I'll know where not to draw. So we're going to draw a few routers here. And for those of you that are not familiar with ISIS, it is an open standards protocol. So for those of you that are familiar with OSPF and EIGRP, very similar to the same concept. It's an IGP. It is a link state protocol. It does do SPF just like OSPF does. And it has the ability to scale, and in my opinion, it scales better than OSPF. And you might say, well, how's that? Well, in OSPF, your area 0 is the backbone, so all areas must connect back to area 0 in order for to communicate with other areas, unless you have a virtual link to a non-backbone area. Therefore, you'd be able to bridge through what they call a discontiguous area. So we have router 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so just for the sake of argument, we're going to go ahead and every link that's what they consider to be a transit connection, which is going to be this guy right here, these are all going to be what they call level 1, level 2. And all the loopbacks that are configured here are enabled, so router 1 can see router 2, 3, 4, or routers 2 through 9 on these connections. On router 1, so router 1 sees router 2 through 9's loopbacks, and he also sees the transit connection. So the idea here is for every connection here, so like 1 to 2, this would be 10.1.2.0/24, like that. So the lowest number and then the higher number, so 10.1.5, 10.5.6, 10.6.7. I'm sure you guys pick up on that. You can do IPv6 at the same time, and I'll talk about that here in just a moment. So level 1, level 2. Level 2 is going to be your backbone. Okay, that's going to be your backbone level. Level 1 is going to be your is going to be considered to be your stub backbone or stub connection. So what I mean by the stub connection is when you have a connection like this, router 8. Router 9, router 4. These guys are going to use another router to get to some other area or some other part of the network. Now, when you get into setting OSP or ISIS up, there's a couple things you need to be aware of. Where in OSPF you would specify like this right here would be, say area 0. Let's draw a circle real quick. I can just back this up one. This will be area 0, then this will be a different area. Then this will be a different area, and this will be a different area. And let's just assume for the moment that this connection between 8 and 9 had a link, and this guy was another area. And this was area 0, this was a 69, this was 58, this guy was 89. In order for anybody in area 89 to see anything in area 34, you'd have to run a virtual link between 5 and 8 and 6 and 9. Well, at least between 5 and 8. You have to have at least one connection to area 0. That is not the case in ISIS. So the way this would work, and if you had a situation like that, what you would do. So let's just assume for the moment that the connections are very similar. So we'll just go in here and draw it out like this. What you would do instead is this would be level 2, this would be level 1, this would be level 1, this would be level 1, this would be level 1. Would that be a valid design? Absolutely. The only thing is routers 3, 7, 6, and 5 would need to be level 1, level 2 devices. Now the reason why that is this guy acts as an ABR, or an area border router. The reason for that is because of the fact that the IS type, now the IS type points to the router's operational status. You also have the option for, and that's the IS type. You also have the option for the circuit type. Now the circuit type is going to be link level specific, right? And this is going to be like your network connection, your point-to-point, your broadcast, NBMA, things like that. If you configure a router and as the IS type to be level 2 only, then the only interfaces, the only option the interfaces can run at is level 2 only. Okay, so you don't have the option or luxury of going through and getting everything else situated like you would with OSPF. You don't have that luxury of going in there and saying point-to-point. When you go in and you configure it as point-to-point, because the circuit type only determines which level you're going to be sending. Are you going to be sending level 1 only, level 2 only, or a combination of level 1 and level 2? You will form adjacencies on both at the same time if you have them enabled. So it's going to be twice the hellos. The hellos, and I should say twice the adjacencies and twice the hellos. If you go in here and you say, maybe this is a level 1 circuit type, but it's a level 1, level 2 router, it's a level 1 circuit type, you can set up to where only on this connection here would you want to run point-to-point, so that you're only sending point-to-point IIH, which is the IS hellos. So once you've gone through there and you've got that situated, you're in pretty good shape. Now let's just assume for the moment that you decide to come in here and routers 3, 4, and 7 all form a LAN connection. You have a backup circuit of some type. The boss tells you router 4 is going to have a backup circuit of some type. So you go in here and router 4 has connectivity to router 7 as well. Okay, so router 8 has a backup circuit to router 6 if he needs to through router 9. So what you would do here on this, anytime you have a LAN segment, you're going to have, and this is going to be any connection where you're going to be sending what they call a LAN IIH. If you have that, you're going to be choosing what they call the designated intermediate system, the designated router in OSPF. Unlike OSPF, ISIS only has one election for this. He chooses one router, not multiple routers, where in OSPF you have DR, BDR. So you hit that election, you go in here and you set it up so that it's automatically determined. The highest loopback will determine that. It is you can influence who does that, but normally you would not. You just let it go. Just be and these are all things I cover. You would simply go to the interface level. Whether this is if it's iOS, you'd go to the interface level. So you type in interface gig 1.10 for instance, and you type in IS priority is say 100, just for instance. Now if it's iOS XR, which we'll be spending a significant amount of time on, you also have to go through here and type in underneath the routing process, so router OSPF, or sorry, router IS1, and then you have to specify underneath the interface, so like interface gig 0000.10, you specify the priority at that point. So once you've done that, you're in pretty good shape. And I walk you through the negotiation of how that works and what you need to know about that. Now, there's we've already touched briefly on the network connections. And one of the things that need to be understood here is the type of network connection determines the type of hello. So if you have a LAN segment like we do over here, up on between 3, 4, and 7, you're going to be sending LAN IIHs. Because by default, Ethernet connections automatically get they call the broadcast or the LAN style network type. You have to manually configure the point-to-point. So let's say, for instance, between 6 and 7, you configure point-to-point. Then you're going to send serial IIHs. That's going to be how you do that. Then you send that out. different hello parameter. So instead of sending a hello every so many seconds, depending on whether it's the designated intermediate system or just a regular LAN every 10-second hello, serial hellos are only sent during the initial spin up of the circuit for the adjacency for ISIS. After that, only changes are sent across. So very similar to the way that OSPF and the demand circuit would work, as well as the flood reduction. So instead of demand circuit and flood reduction in OSPF, if you with the demand circuit, you're not going to send the every 10-second or whatever the hello interval is configured for across the wire. This is for the old legacy like ISDN or your 56K modem or your very slow link speed connections. You're going to turn off the hello mechanism, and you're also going to turn off what they call the do not age bit. Or I'm sorry, you're going to turn on the do not age bit. What that's going to do is it's not going to age out the LSAs in the routing table. Only when a update is required is an update sent. Same thing with hello. So just like with OSPF, you can choose the network type, and that's one of the nice things about that. So again, you'd have to manually specify the point-to-point connection underneath the interface. If you want to go back to a LAN, you simply just negate the point-to-point connection. Now, when it comes to authentication, authentication is possible in ISIS. There were multiple ways before. You could do it through the domain, you could do it through the area, you could do it through the, actually that's horrible handwriting by the way. You could do it through the domain, you could do it through the area, you could do it through the, and the interface. Now, they've deprecated a lot of this stuff to where it's no longer the domain and area are gone away, and they replaced that with LSP. They have LSP password and hello password are going to be your configs for iOS XR. On iOS, it's going to be ISIS authentication, and then if this is at the interface level, and if it's at the process level, it's going to be authentication. The difference between these two, interface level is just going to be hello authentication, and then at the process level, it's going to be LSP, or link state packet authentication. You can do both, and we'll take a look at how that would work. There is some caveats in order to get that to work. Now, since we talked about that, it's also important to talk about, before we get into path selection, IPv4 versus IPv6. Now, by default, iOS for both v4 and v6 it is possible to run. In order for it to work, though, in order to run v6, you need to enable what they call metric style wide. Now, I'm not going to get into the nitty-gritties about that here, about how the metric style changes. It actually becomes a bigger metric value, and I will cover that in the SP course. But what it also does is it allows you to do different TLVs for like MPLS traffic engineering, things like that. That's why it's going to be so. I enable it as soon as we get started inside of the setup, as well as in iOS. IPv6 defaults to what they call single topology. Now, single topology, if you're not familiar with that concept, basically means I need to go out there, and in order for me to run v4 and v6 at the exact same time on the same link between me and another router, or router depending on the connection, v4 and v6 had to be enabled on every interface. It had to be actively forwarding traffic on every interface. What do I mean by actively forwarding traffic? Sending hellos. Now, in order for this to work, you need to have one-to-one parity. One-to-one parity means every interface has to be running v4 and v6 in order for it to work. If this is not the case, you will black hole your traffic because it's going to try to form the adjacency. iOS XR does what they call multi-topology. Now, with single topology, what you're actually doing is you're doing one SPF run for both v4 and v6. With multi-topology, you're running separate SPF runs for v4 and v6, so you can have different forwarding mechanisms. So you can have, say for instance, you can have v4 and v6 running here, but only v4 here. And then you would be, and you can have running v6 here and then v6 only here. This is a valid topology, a valid design if you're running multi-topology. iOS XR runs it by default. If you want iOS to run that, you have to go underneath the address family IPv6 unicast address family and enable multi-topology. So the first two things you're going to want to do as soon as you turn up ISIS in iOS is router ISIS and then the tag, which is going to be like 1 or a alphanumeric, so a name if you would like. The net address, and I'll talk about the net here in just a moment. I actually forgot to cover that. The net, which is going to be the value of the route, so the area, and then the system ID, and then you have the end cell, which is going to be 0 all the time for everybody because it's a router. And then you have to go advertise metric style wide. Now you can use transition, which is going to advertise both narrow and wide metrics. I disagree with that option. If it's an exam and you're going for it, and it tosses you a question that you're in transition between going from moving from V4 to V6, and you have some legacy devices that don't support wide metrics, then your option is transition. So I would do wide if you have the option to do so. And then from there, what you would do is you would go underneath IPv6 and enable multi-topology in iOS. Pretty easy stuff for the most part, but important to understand. Now let's talk about this net thing, since we've already covered pretty much all this other stuff. So the net, or the network entity title, is going to be basically the router ID, for lack of a better term. But it's also going to have some other major impact to it as well, where the net is actually broken down into several different parts. The main factor for you to understand about the net is the fact that when you're dealing with it, there is multiple portions to it, and I will explain that here in just a moment. So the net itself, or the network entity title. The network entity title is going to be broken up into 3 sections. You have the area identifier. So 49, you'll see that. It's actually broken up, it looks something like this. We'll say X, X. Let's just do it this way. X, 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 X. Actually, I missed an X. I'll just draw zeros, it'll be easier. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0. There's actually a dot here and a dot here. So it's actually an 8-byte value. So you've got 6 bytes here, and you have a byte, a nibble here and a nibble here. So you get 6, 7, and then theoretically 8. Well, it's actually it is a total of 8. So you have that. Now the key factor here to understand is this value right here is negotiable. So typically what they would do is with the 0, 0, this is, I'm going to pretty much always make this a 49. This is the area identifier. So the first thing you do, actually let me break down the net first, and then you have the 0, 0, 0, 0. This right here is the system ID. So this is the area. This is the system ID. This identifies basically the router ID. System. And then you have 0, 0. This is going to be the end cell. This identifies it as a router. This is always going to be 0. So when you configure it, it's always going to be 0. Now the area can be manipulated. So typically I'm going to draw it out as 49, which means it's a private address. It's not a hardened fact. This is 49 typically refers to RFC 1918 space. And then I'm going to do this. I'm going to say 0, 0, 0, 0. This does not mean area 0. This means it does mean area 0, but not in the same context that OSPF does. So area 0 as in this is area 0 identified as these zeros. And then down here I would type in the system ID. So typically I use the first 4 blocks are going to be all zeros, and the third octet, the third block of zeros, I typically use the router's interface IP address. So if this was 8, I would use 0008. And that's how I would do this. Now, if you're going to be dealing with multi-area ISIS, this value right here is where you would change that. So I would come in here and type in 490000 would be 1 area, and I would have 490001 or 10 or 30. The number is arbitrary. You can use whatever you want to get the job done. Just make sure you know that. And then in order for ISIs to come up, now I've done this in testing to see if it would work. If you do not configure a net address, IS will not come up. Because it's the same thing as OSPF or EIGRP or BGP not having a router ID. How do I identify myself in the network? Well, you can't. That's what the net is for. It's analogous to the router ID, but it's more. There's more to it than that. So that's how I would incorporate that. Now, once you've got this configured, so if I was to do this for router 1, my configuration would look like this. It'd be 49.000. Actually, let me do it down here. I'd have more. Let's do it for router 9. Router 9 would be 49.0000 for area 0. 0.0000000 dot there, a dot there, 0.009.0.0. That would be my net address. Because then I can go up here on router 6 and I could type in 49.0001. And then all of this across to 6.00. What that's going to enable me to do, which is actually really cool, is now router 6 and router 9, this connection right here becomes a level 2 adjacency, level 2 connection, because they are in different areas. They have to be level 2 between the areas. So because this guy's got a different area identifier than this guy, 2 different areas, they have to have a level 2 adjacency. And that's how I'm going to demonstrate a lot of the stuff we do. That's how we're going to move forward with it. Now, when it comes to doing stuff like that, you do have the option of doing path selection. There is a way to go in and manipulate the thing in global config. There's also the ability to manipulate the cost at the interface level. There is no technically a cost, it's a value. By default, it's a value of 10 for the cost. There are, like for instance, with the designated intermediate system, the priority is 64 by default. That can be raised or lowered. And higher should be better. So if I'm going to be doing the cost on a 10, if I want to choose, say, this path, I would lower the cost to, say, 5, and that's going to choose this path to get off the network. Things like that. There is also the ability to do what they call route leaking. Route leaking, basically, the idea of that is to take routes that are in level 2 and redistribute them into level 1. Because by default, level 1 is going to use a level 1, level 2 to get to level 2. Because level 2 will already know how to get there. So what I'm going to do is if I need, and the reason why I bring this up is, let's say for instance, router 1 is a PE in an MPLS environment, and then router 9 is a PE in an MPLS environment. Now if that's the case, and these guys are in different areas, and let's say this guy right here is he has level 1 adjacencies to 6, and router 9 can't ping router 1, or they can't trace via the loopbacks to each other, therefore they can't form an LSP, or label switch path. So what you would need to do is on 6 is you need to redistribute leak the route from level 2 into level 1 in order for router 9 to know about the connection to router 1. So this is how you would manipulate that, and you would create a prefix list to match the route, call it in a route map, and then map that in ISIS. Now if it's IOSXR, you would configure you could either do it for a prefix set, which is like a prefix list, and then you have to call an RPL, or a routing policy language, and then you'd have to call this guy, pass the traffic, and then associate the RPL in ISIS, in IOSXR, to take routes from level 2 into level 1 in order for R9 to learn about that. Because level 1, or router 1 is going to know about router 9 because it was advertised via router 6. So he's going to know how to get there anyway. The thing with level 1, if you're dealing with that, is router 9 is only going to see a default route for any level 2 routes. Where he'll see a level 1 route for all of the intra-area connection. Anything outside of his area or in a different level, he'll have just a default route to the router that owns the routes to that. So again, it's like distance vector routing for OSPF, like an ABR. where the ABR is going to advertise routes from other areas to the area that you're in, and then you're just going to recurse to the Type 3 LSA, which happens to be the ABR's LSA. The ABR is going to say, I already know how to get there, so just learn how to get to me, and I'll get you where you need to go. So, routing by rumor. So we've already talked about the IS type and the circuit type. And a lot of pretty much everything that I'm talking about here, when it comes to authentication, inserting routes, the timers, everything like that, everything can be done on level 1, level 2, or both. So if you're going to manipulate it for level 1, so like, we'll say for instance on router 5, for level 1 hellos, you want to set the hello timer to be 20 seconds. And for level 2, you want it to be 32. You can manipulate on a per level basis because they're individual adjacencies. If you do not specify level 1, level 2, it's going to do it for both. So there's an implicit level 2, level 1, level 2. That is the default IS type of all IS-IS routers that are running on Cisco iOS and iOS XR. So just be aware of that. Now level 2 routing, if you're not familiar with that, level 2 routing basically is backbone. So let's say for instance that you're not going, you don't need to go off the deep end. And let's say for instance you're ramping up for service provider CCIE like I am, and you get a particular topology where you don't need to go in and do any fancy configuration with ISIS. They just want you to go in there and maybe authenticate something and then configure the DIS to be a specific router. But every router needs to have an exact copy of the routing table, and it needs to be backbone. Well, I'm going to do level 2 automatically. So I'm going to configure the IS type to be level 2 out of the gate, and then I'm going to go from there. That's going to be how I go about getting everything situated and working. Level 2 is going to be backbone only. You're not going to be connecting to a level 1 area at all. And go from there. You can summarize with an ISIS, and it is, to my knowledge, it's only in, you can summarize only at ABR areas, so like level 1, level 2. And I believe you can do level 2 as level 2 summarization. You can do a default route, so you can originate a default route if you'd like, or do a redistribute static. And there's also the ability to do what they call BFD, or bidirectional forwarding detection. I'm going to throw this out now. iOS XR does not support BFD. So I will run through the configuration and stuff like that. One of the things that needs to be also known and understood is when you're dealing with ISIS or iOS XR. For those of you that are studying for any of the higher level certifications, if you're studying for CCIE, CCNA, things like that, and you work in the real world, specifically CCNP, CCIE, when I did my research to ramp up and determine what I needed to teach for this particular course, I found the CCIE service provider CLN page, and the program managers from that particular track have done a great job of letting you know what you will and will not need to worry about on the lab. One of the things that they were very, very clear on was if something can be configured and can be verified in the control plane, but the data plane may not work, then it's still a valid topic. Just because BFD doesn't work doesn't mean you may not be asked to configure it and do some sort of verification. So I know it does work on iOS or CSR 1000V on iOS XE. It does not work, at least in the 5.3 code, for CSR 1000V. I have not tested that in Viral. I have yet to come back. I have to come back and do that to see if it works, and then do a packet capture to see if it actually would work. That's another thing that I'm going to be doing too through the. It hasn't actually been signed, but I'm pretty sure they're going to go forward with it. Is I'm doing a service provider series on the service provider tech on iOS and iOS XR. And so the whole point of this particular feature and series is to zero in on the concepts and cover them. So one of the things that is going to be done a lot is we're going to be looking at debugs, we're going to be looking at trace routes. If something can't be verified via the data plane, which is a ping or a trace, we're going to verify it in the control plane. So we're going to do packet captures to see the actual data going back and forth and things like that. I'm working on a very, very large-scale packet capture zip file where I'm going to be taking packet captures pretty much on every topic to some level and looking through it to make sure that we can see what we need to know about in at the wire level, because that's going to help everybody reinforce what they're seeing. It's one thing to go through and um, hear me explain something and maybe draw it out, and maybe not a very accurate drawing. That's another thing to see in the Wireshark capture, because then you're seeing exactly what the frame headers look like and how many bytes they're associated to, what bits equal what. And I've got it set up to where that'll be on a pretty regular basis. We'll be doing that and going from there. So that is what you can look forward to. I am actively working on building the workbook. I'm not sure how that's going to work out yet, if we're going to be doing just a how that's going to work out. I will give you guys an update on that soon. Until then, you guys have been awesome. I would like to thank you for all the support. Until next time, you guys take it easy. Be good to each other. If you have questions, drop them in the comments below. If not, I'll see you in the next video.